Hello everyone, welcome back to my channel and I hope you all are doing great. In this video, we are going to talk about conductor, semiconductor and insulator, and we'll be learning about this thing through the comparison. So let us first try to understand how they are related, okay, and how we can compare first. So first, when we talk about conductors, the name itself says that okay, it can conduct. Okay, means we will differentiate among these on the basis of conductivity. So what is conductivity? So conductivity is something that allow the device or the elements or the thing to conduct, to it enhance, or you can say it is actually the ability how well there is the flow of electron, how well the current can pass through it. Okay, so this is the ability of any substance or the thing to conduct, the ability of any substance or the thing to allow the flow of the current, how easily the flow of the current can happen in that substance. That is the conductivity. So when we compare, the first thing that here we are saying, the conductivity. The conductivity of the substance is denoted by the Greek letter called sigma. Okay, so sigma here, conductivity, it is the inverse of resistivity. Here we are saying the two thing are there. One is conductivity, one is resistivity. Resistivity, it is the ability of the substance to how much it will stop the flow of the current, means resist, how much it is resisting, how much it will create the hurdle to the electron not to flow. Okay, and in the case of conductivity means how much it is the ability of any substance, how easily the electron can flow, how easily the substance can conduct. It is the conductivity. Okay, so the unit for the conductivity is mho. Mho is like the inverse of ohm. Okay, you can write, you can hear mho, or you can also say Siemens. Okay, Siemens is denoted by S. So the conductivity of, since we know that in the conductor all the metallic thing, okay, all the metallic elements, they have abundance of electron. So in the conductor the number of electrons are in a large amount. Okay, so the conductivity of the conductor is very high. The conductivity is very high. Conductivity is very high. Okay, and now let us take the case of semiconductor. In the case of semiconductor, what happened? The semiconductors are those kind of elements or the substance whose conductivity lie between the conductor and the insulator. Okay, so here the conductivity is moderate. And in the case of, remember in the previous video we talked about electrical devices and the electronics devices. In electronics devices we use semiconductor, because in semiconductor we can control the flow of the charge and we can control the control of the current, we can do in the case of semiconductor. So here we can say the conductivity of the substance is moderate. And in the case of insulator, we say insulator is something that has very less conductivity, or you can say no conductivity. Okay, so it is very less. Very less conductivity. Now, let us try to understand, let us try to see how much is the conductivity value. Okay, if we say the conductivity of conductor, conductor having the high conductivity means the conductivity value will lie from 10 to the power of 6 to 10 to the power of 8 Siemens. Remember we say the Siemens is the value is the unit for the conductivity. So Siemens per meter. Okay, its conductivity value lie between 10 to the power of 6 to 10 to the power of 8 Siemens per meter. And now for the semiconductor, its conductivity value lie between 10 to the power of 10 to the power of minus 6 to 10 to the power of 6 or 4 Siemens per meter. Okay, and now in the case of insulator, the conductivity is very less. Okay, so we can say the conductivity lie from 10 to the power of minus 10 to 10 to the power of minus 20 Siemens per meter. Okay, and here also we can see this is the here the conductivity is very high, here the conductivity is moderate, and here the conductivity is very less. And now if you see here, we have seen the relation between conductivity and the resistivity. And if you see, if the conductivity is very high, then it is sure that your resistivity will be very low. So resistivity means what? It is resistivity means what? Resistivity means it is the ability of the substance to resist the flow of the charge, and this lead to means your less if the resistivity is high, means the less current will flow through that substance. If the resistivity is low, means the more current will flow through the substance. Now in the case of conductor, here conductivity is high, means it is inversely proportional to the resistivity, means resistivity is low. Okay, resistivity is low. And yes, in the case of semiconductor, resistivity lie between the resistivity of conductor and the insulator. So resistivity is moderate. Resistivity is moderate. Okay, and now in the case of insulator, resistivity is very high. Okay, resistivity is very high. It means that it is resisting the flow of the charge so much that very less amount of current is flowing through that substance. Resistivity is very high in the case of insulator. Now let us see talk about the temperature coefficient. Okay, let us talk about the temperature coefficient. What is temperature coefficient? Now temperature relation coefficient or temperature coefficient, if you talk about these three things and we will compare, means the behavior of the substance when we are providing heat, or the behavior of the substance when the temperature is increased. Okay, what happened to the conductivity, what happened to the resistance when the temperature is increased, what happened to the resistance when the temperature is increased. We know that if you see, we know that resistance is denoted by R. Okay, R means resistance. It equals rho L by A. Here R is the resistance, rho is the resistivity, L is the length, and A is the cross-sectional area of that substance. Okay, so we are going to understand the relation between the resistance here and the temperature. If we increase the temperature, what is going to happen with the resistance, whether it will increase or whether it will decrease. So let us try to understand. So that is called the temperature coefficient or temperature resistance coefficient. Okay, now in the case of conductor, okay, now there are two things. One is positive temperature coefficient and one is negative temperature coefficient. Okay, so we will now discuss about the temperature coefficient. Okay, temperature coefficient and its relationship with the conductor, semiconductor and insulator. With the increase in the temperature, when the resistance is increasing, means it is called positive temperature coefficient. It is called PTC. With the increase in the temperature, if the temperature is decreasing, it is called negative temperature coefficient, called NTC. And again, for the insulator, with the increase in the temperature, the resistance is decreasing. It is also called the negative temperature coefficient. So it has negative temperature coefficient relationship. So how it is happening, let us try to understand. Means when the temperature is increasing, although there are the number of electrons in the conductors are abundance. Okay. But with the increase in the temperature, they will start to vibrate. When they start to vibrate, the mobility of the or the electron in a particular direction, it decreases, means it is creating hurdle to the flow of the charge of the electrons. Okay, it means the resistance is increasing, means with the increase in the temperature your resistance is increasing, positive temperature coefficient. Now let us try to understand in the case of semiconductor. In the case of semiconductor, with the increase in the temperature, the resistance is decreasing. How it is decreasing, let us understand. When the when the substance is heated, when the temperature is increased, the elements which are bonded together through the covalent bond, they breaks up. When it breaks up, then the number of electrons, you are getting the number of electrons, the carrier number of carrier more. So when there is more number of carriers, they will start to flow. When they start to flow, means the resistance is decreasing. When the resistance is decreasing, means there is temperature. With the increase in the temperature, resistance decreasing, it means negative temperature coefficient. Same in the case of insulator. With the increase in the temperature, your resistance is decreasing, means negative temperature coefficient. Okay. Now, let us understand the difference among the conductor, semiconductor and insulator through energy band diagram. In the case of conductor, the conduction band and the valence band are overlapped. Okay, and in the case of semiconductor, the conduction band and the valence band have an energy gap between 1.1 eV to 5 eV. In the case of insulator, the conduction band and the valence band are highly separated, they are far apart, and it is with the energy level of greater than energy gap is greater than 5 eV, or you can say it lie between 6 to 10 eV. Okay, now let us try to understand about the valence electron. Valence electrons are those electrons that are in its outermost cell. The number of electrons found in the outermost cell of any elements. So valence electron in case of conductors are either you can find 1, 2 or 3 number of electrons on its outermost cell. In case of semiconductor, valence electrons are 4, and in case of insulator, valence electrons are 8, 7 and 6. Now, what happened to these elements when they are subjected to the temperature of 0 Kelvin? Let us try to understand. At 0 Kelvin, conductor will behave as it will behave as semiconductor. Okay, it will behave as semiconductor. And at 0 Kelvin, at temperature is equal to 0 Kelvin, semiconductor will behave as insulator. Okay. In case of insulator, at temperature is equal to 0 Kelvin, it will behave as insulator only. Okay, so this is all we have in this video. I hope you like this video, and tell me if you need the video like this in the upcoming future. See you in the next video, and I hope that you are enjoying my video. Leave some comment and follow for more. Bye.